Animate and Inanimate by William James Sidis. Chapter 14. The Reversibility Theory of Cosmogony. We have seen that, according to the results of observed facts, it seems probable that the pre-nebular stage of a star was a negative, a living condition. Now let us see what would be the theoretical result of supposing our theory of a reversible universe, as far as such results may relate to cosmogony. We have seen that the structure of the universe, according to the theory of reversibility, is that it consists of irregularly shaped sections, alternately positive and negative. In the positive sections all heated bodies give out radiant energy, according to the second law of thermodynamics. In the negative sections, on the contrary, hot bodies, instead of giving out light or other radiant energy, would tend to absorb it and convert it almost entirely into heat, thus heating themselves up with light received from outside sources. This is in strict accord with the reversal of the second law of thermodynamics. In the first place, when we examine the changes that take place in time, we may first notice that the structure of the universe probably remains somewhat the same always. The positive and negative sections do probably indeed change their position, but, on the whole, such change would consist of a general motion of all the sections alike through space, so that the sections do not move relatively to one another. Further, there may be slight changes in the shape of the various sections. But by far more important is the motion of the individual stars relative to the various sections. The motion of a star, being uniform motion in a straight line under the law of inertia, the infinite universe assuring us that there will be no gravitational disturbance unless by accident the star should come very close to another star, will have the result that the star will constantly be crossing from one section of the universe into the next, from a positive section into a negative, and from the negative section into another positive one, and so on ad infinitum. In a positive section of the universe, the star, which was at first hot and bright, radiates its heat into outside space, and gradually becomes cold and dark. We have already seen, in Chapter 5, that, as this cooling process goes on, life gradually extends itself at the expense of the opposite, the positive tendency, until, when the cooling process is well underway, life has absorbed practically all inorganic matter, leaving as non-living matter the organic compounds formed by life, which it builds up into pseudo-living organisms. We may suppose that, when a stellar system crosses over from a positive to a negative section of the universe, there happens this slow process of development, of life growth, changing the star from a positive one to a negative one very gradually. To trace this process of development farther, we must note that the evolution of living stars and planets consists to a great extent in their absorbing radiant energy from outside space and using it to build up higher heat levels in themselves. The life of these stars and planets depends on their being constantly fed, so to speak, with radiant energy uniformly from all directions, which is something that is not obtainable in the positive section of the universe, where the distribution of light is very irregular. In the negative section, however, we are surrounded by positive sections, and in such a way that the light obtained from them is approximately uniform, so that the negative stars and planets contained therein can be properly fed. The tidal forces produce, under those conditions, not tidal friction, as they would under the positive tendency, but a sort of tidal irritation, speeding up all motions of rotation, etc. These living stars and planets, building up in themselves ever higher levels of heat, finally pass into the molten and then into the vaporous stage, and finally the star develops a nebular stage, this nebula taking a spiral form on account of the rotational motion of the star, ever increasing through the process of tidal irritation. Thus we get to a nebular stage, and the dissociation of atoms that goes on in the last part of the negative stage, when we have great heat, will make the stellar system largely one that is constituted of hydrogen, the smallest atom known. Meanwhile we might expect that not only the star and its planets, but also a number of small masses on the star, would have life, that is, would follow the negative tendency, besides the existence of a number of pseudo-living organisms. These simple living masses would, when in the heated condition, also tend to live by absorbing radiant energy from outside space. Now, we may suppose that, after the nebular stage has been reached, and the star and all its planets are but more condensed vapors in the nebula, the stellar system in question finally comes toward the end of that part of its path which is in the negative section of the universe. The stellar system, nebula, and all, is quickly approaching the boundary surface, with the positive section shining brightly ahead of it. The sudden absorption of an immense amount of light from the front will tend to cause a great, sudden, additional building up of heat, so that we will have an immense amount of heat developed before the boundary surface is finally reached. Star, planets, nebula, and all, are constantly absorbing ever more and more heat, including also the smaller living masses on the stars and planets, with the possible exception of the pseudo-living organisms. All are dependent on the constant accession of radiant energy to sustain their life. Now, when the system comes near the boundary surface, when it is on that surface or very close to it, the accession of radiant energy suddenly ceases to be uniform in all directions, and, once the boundary surface is crossed, no light whatever is received from behind, because light crosses the boundary surface in only one direction, that from the positive to the negative side. The uniform access of radiant energy that the system has to feed on is suddenly cut off, and the stars and planets can no longer continue to live. The proper supply of radiant energy food being suddenly cut off, the death of the system results, and therefore, after crossing the boundary surface, if not a little before, there occurs in the stars and planets of that system the transition from the negative tendency to the positive. As we have seen before, in Chapter 9, the transition in this direction might be theoretically expected to be a sudden and complete one. Hence, somewhere near this boundary surface, we might expect a sudden reversal of this process due to the death of the system, to its suddenly ceasing to be alive as it was when in the negative section of the universe. And the moment this transformation occurs, the second law of thermodynamics immediately begins to apply, and the heat of the system being at a higher level than that of outside space, would suddenly begin to spread itself at a rapid rate into outside space by a sudden outburst from the star of radiant energy. The nebula, being more scattered, gives out much less light, but has to be lighted up to a great extent by the central star. This will produce the phenomenon of the nebula in motion as seen in Nova Persei in 1902. In other cases, the nebula itself will give out enough light to be visible immediately. However, this reason for the death of the star, planets, and nebula, does not by any means apply to the smaller living masses that existed on those bodies. The pseudo-living organisms that formerly existed on those bodies will then, with very little change, become simply inanimate bodies, but the small living bodies, unlike the stars, planets, etc., will suddenly get a new and possibly better supply of their food, radiant energy, from the flare-up of the star. Instead of having to depend on the radiant energy coming in from a distance, there is suddenly opened up for them an immense new supply of light on the star itself, or on the planets. The small living bodies thus begin to feed on the dead bodies of the stars and planets. The death of the stars and planets gives an opportunity for new life to develop as a sort of parasite on the dead bodies. From this survival of life, further life on the planets of that system is descended. After this sudden flare-up, the light and heat would then proceed to fade out gradually, and the system would continue to evolve along the lines indicated by the planetesimal hypothesis, this being the precise reverse of the evolution as it took place before in the negative section of the universe. Finally, the worlds cool off, life extends, and, by the time that the system leaves the positive section, life has again gradually extended so as to take on the large bodies. Now the cycle is complete, and we are back at the original stage.